This is an extra video on the Gaussian integral. So let's recall, if x is a normal random variable with expected value mu and variance sigma square, then we know that the probability of this x takes the specific value small x is 1 over square root 2 pi sigma square exp, that is exponential of negative x minus mu square divided by 2 sigma square. Okay, and if we have mu is 0, that means 0 mean, and then variance is 1, that means standard deviation is 1, then we replace this expression, everything sigma become 1, everything on mu becomes 0, then we get the so-called standard z-score, right? The probability of x is a small x will be what? In this case, it will be 1 over square root 2 pi, and then what? Negative x squared divided by 2, okay? So this is the probability distribution of a standard random variable, that is the mu 0, sigma 1. And then for this kind of a random variable, we usually denote it as z. The probability of the standard z-score bounded between two values a and b will be what? Will be this thing, okay, put it here. Okay, integrate from a to b, okay? And then now I'm going to do some variable transformation. Now I'm going to what? So now I move the 1 over square root 2 pi outside, so I will 1 over square root 2 pi, okay? Integration from a to b, right? Okay. And then now I'm going to do something called change of variable. So instead of z divided by 2, I'm considering z divided by square root 2 and then whole thing square. Okay? So now I have dz. Okay? What I'm going to do? I'm going to divide it by square root 2, and then now I'm going to multiply it with square root 2. Then the what? The square root 2 and the square root 2 cancel out. I got this. And now I rename z divided by square root 2 as x. This is what? dx. This is negative x squared. And let me tell you a fact. If you integrate this negative x squared dx from negative infinity to positive infinity, it will be what? Square root pi. If this term from a is negative infinity to b is positive infinity is pi, square root pi, then to make the whole thing 1, we divide it by square root pi. So this is the reason why there's a 1 over square root pi in front of the probability here. Now we have a fact. Integration of this negative x squared from negative infinity to positive infinity is square root pi. In other words, if I plot this function as this curve, it's saying that the area under the curve from negative infinity to positive infinity is what? The area is square root pi. Okay? We are going to talk about why and how. I let the integral as I, so integral I equal to negative infinity negative x squared dx. Okay? Now I consider I squared. What is I squared? The whole thing squared. And if I write it down as two specific brackets, I have this. So I is the integral, and now I consider the square of the I, so I have the bracket square, and I can expand the bracket. Now I'm going to do a magic move. Now I'm going to rename the second x as y. Okay, what I'm doing here is x become y. Okay, I can always change the name, right? Then what I'm going to do, I'm going to combine these two integrals. So I combine these two integrals, I have this. And then these two terms, I can further combine them. So now I have a double integral, okay? So now let xy in the Cartesian coordinate or rectangular coordinate and polar coordinate r theta be related by foreign. So x is basically r cosine theta, y is r sine theta. So what I'm going to do is I'm going to convert dx dy to dr d theta. I'm going to do a coordinate transform. Then dx dy will be related to dr d theta multiply a number which is the determinant of a 2 by 2 matrix. This is called a Jacobian. What does it mean? It means the partial derivative of x with respect to r, and the partial derivative of x with respect to theta, the partial derivative of y with respect to r, the partial derivative with respect to theta. And now we plug in this xy into this expression. So now we plug in the x and y as r cosine theta and r sine theta. Then we perform partial derivative. That is, here we only care about dr. Here we only care about d theta. We don't care about r. We treat them as constant. So now we get this term, and then we take the determinant of this matrix, which is this term multiply this term, subtracting this term multiply this term, that is so we have this. So in other words, dx dy is the same as r d theta. So dx dy is r d theta. And because x and y is defined like this, so x squared plus y squared will be r squared. And we are integral from negative infinity on x to positive infinity of x, and the same for y. This is the same as we integrate theta from 0 to 2 pi, that means the whole plane, 360 degrees, and for r from 0 point to infinity. So we have this integral. So then the following is to evaluate this. Okay, then we have two integral. This one is on theta alone, but we have no theta, so we can split them. So we have okay, we have this thing. This guy is basically theta from 0 to 2 pi. This guy is r from 0 to positive infinity. And then here I have, okay, I absorb the r into the dr, which will give me dr squared divided by 2. Then the first term gives me 2 pi. And the 2 pi cancel out with the half, give me pi. Then I have this. Then what I do change of variable. I change r squared to u. Then I have then you know how to integrate this, right? This is 1. So you have pi. And how do we get here? We are going from I squared equal to this thing, 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 up to here. So I squared is pi. So I squared is pi. What is I? I is pi square root. What is I? So that's why this integral is square root pi.